This is the MyDAC Lab 3 video tutorial. The objective of this lab is using MyDAC to create and solve a superposition theorem circuit. Some background on superposition is that the superposition theorem for electric circuits states that for a linear system, the response voltage or current in any branch of a circuit having more than one independent source equals the algebraic sum of the responses caused by each independent source acting alone. In this theorem, you only consider one source at a time to find the responses. So for part 1, we will be using the NI Elvis digital multimeter, the NI Elvis digital writer, the breadboard, and given resistors to create a superposition theorem, or superposition circuit, and find V. To start, use the superposition method to calculate the value of VA in the circuit shown below in figure 1. Let R1 equal 1 k ohms, R2 equal 4.7 k ohms, R3 equal 3.3 k ohms, and R4 equal 2.2 k ohms. Both sources, V1 and V2, will equal 3.3 volts. Using superposition, you short voltage sources and open circuit current sources. In order to find VA, VA prime and VA double prime must be found. To do this, start by shorting V2, which results in the circuit shown in figure 2. Next, you short V1, which results in the circuit shown in figure 3. Finally, you use VA prime and VA double prime, you add those together and that gives you VA. So for shorting, when we short V2, we get figure 2, which gives us V1 and R1 and R2. V1 equals 3.3 volts, R1 equals 1 k ohm, and R2 equals 4.7 k ohms. So to find VA, we use the formula given here, R2 times V1 over R1 plus R2. And so it is 4.7 times 3.3 over 1 plus 4.7 k ohms. The result of this gives you gives you 2.72 volts in the positive direction. As you note, the current flows around this loop as the arrow shows. For figure 3, this equals VA prime. For figure 3, you have VA equals 3.3 volts, R4 equals 2.2 k, and R3 equals 3.3 k ohms. Now VA double prime equals negative R3 times V2 over R4 plus R3, which is 3.3 k times 3.3 volts over 2.2 k plus 3.3 k. VA double prime in this one equals negative 2. And it's negative 2 because we established that clockwise was our positive direction, and this one is flowing in the counterclockwise direction. So VA equals VA prime plus VA double prime. VA equals 2.72 minus 2, which equals 0.72 volts. Now that we know what we are supposed to find for VA, we can go on to creating the circuit on our breadboard. To start, open up the NI Elvis. To do that, you go down into the Start menu if you have Windows 7, or you search for it on your Windows 8 computer in the Tile menu. So once you have NI Elvis opened, you need to open up the DMM, and you need to open up the digital out. And this gives you these two windows. We have used the digital multimeter before. We need to remember to change the range to 20 volts on this. And then the digital writer gives you 7 ports. We only need to use line 0 and 1. Line 0 is tied to the breadboard, which is DI0 or DO0, and line 1 is DO1. And when you flip the switch to a 1 or a high, it'll make that line put out 3.3 volts, and when it's in a low, it puts out 0 volts. So this will be your V1, and line 1 will be your V2. Now onto the breadboard, we need to wire our circuit as shown in figure 1. So we take our R1, which is 1 k ohms, and put it in series, and you put it in series with R1 in series with your 4.7, which is R2, which looks something like this. And then you take your R4 and put it in series with your R3, so your 2.2 k ohms in series with your 3.3 k ohms. And because of how it's wired, you can put the rear end in the same line as your 4.7, just like that. And then you need to ground this line also. So take this one and wire it to a ground source there. And what that is that's your V1, this yellow wire is your V1 negative and your V2 negative, because that's both just your ground wire for both of them. So now the green wire is V1. We put in DO0 and we wire it to the R1, the left side of R1, and then the orange wire will be V2 positive end, which goes in your DO1. You wire it to the right side, the positive side of R4. So this is how you need to wire your circuit in order for it to work. And then you need to connect your probes to your DAC board, and you will use these probes to make your measurements. Now for this one, we do not need to open anything in the lab view, block diagram, or front panel, as this we will be using the digital writer to turn on or off our inputs. So once you have your circuit diagram wired up, you can turn both line 0 and line 1 off and hit run on the digital writer and run on the digital multimeter. And if you go and take your measurements, which you want to do across VA, and VA positive side is the right side of the 1 k ohm resistor and the left side of the 2.2 k ohm resistor, you will read 0. Now, to get VA, you will need both of your 0 and 1 ports on high. And then you go back to the same reading, you connect your probes, and you can see that we have 0.72 volts, which is what we found for VA. And to change that, you go, or to show VA prime, you turn off line 1, and you can see that we are reading 2.66 volts, so close to what we found. And then if you want to read VA double prime, you turn off line 0 and turn on line 1. You can see that we're reading negative 1.95 volts. So roughly what we found, and then with both lines on, you get VA, which is 0.72 volts, which is exactly what we found it should be. So that is part 1. And then part 2 states, create a VI that uses shift registers and build array blocks. For this one, we will not need the DAC. We will use for loop and arrays, for loop arrays, shift registers, and build array blocks in the lab view, front panel, and block diagram. So to start this, build a for loop by clicking over in the block diagram. Go to programming, go to structures, and click on the for loop. Click and drag your for loop, and then make your iteration 6. So you want to set n, you want to create a constant for it, and put 6 in there. Next, we want to add a shift register and an element. So you right click on the edge of the for loop and go down to add shift register, and then we want to add another element. So you right click on the shift register and click on add element. Now in order to use our shift registers correctly, we need to assign a constant to both of them. So assign a constant of 0 to the first one. So create constant. First, let's set up the insides of the array so that we can give them a number. So that, because right now the shift registers aren't defined as whether they're Boolean, double, anything. So that's why I couldn't create a constant there. So you have what you're supposed to make it look like on the inside. So we need to add 2. We add 2 numeric adding blocks. And then we need to connect the first one and the second one both to I. So we bring I over to the first one and to the second one. Then you connect the first one to the shift register here, and then that defines the shift register. So now we can go in and do a create constant of 0 for the first one and 1 for the second one. Now let's run our first shift register over to our first addition and our second one over to our second addition. And then we need to make an array for the output. So run your first addition to the wall and your second addition to the wall. And then right click on it and do create indicator. And that'll automatically build you an array for the first one, and you can do that for the second one too. So now we have our 2 arrays built, array 1 and array 2. And now when we run this, it will fill our array with 6 different values. Array 1 is adding from 0, and it's taking the iteration of the previous section and adding it to it. So we have 0, then it's 1, and then the iteration on the second one is 2 plus 1, 3. And then we have the third time it runs, 3 plus 3 is 6, fourth time 6 plus 4 is 10, so on. And then the second array, we start at 1, and we add 0, which we get 1, and then we add 1, 2, 2, 4, 4 plus 3, and so on. So we end up with these 2 arrays here. And now we want to concatenate these arrays with a build block array. So to do that, you right click on any array wire and go to Array Palette and click on Build Array. Place Build Array and then go to the bottom portion of it and drag it down so that you can have 2 inputs here. So connect each array to each input, and then right click on the build block array and check concatenate inputs. What this does is it concatenates both inputs and makes it a 1D array. If you don't concatenate the inputs, you'll end up with a 2D array. And our goal here is to append the arrays to make a 1D array. So you can create an indicator for this build block array, which has been named appended array. And then we can run it again. And when we pull it down, you can see that it's taken array 1, which is our first input, and placed it in the appended array, and it's concatenated or appended to the bottom of it array 2, which we had as our second input. So the build block array takes the first input, places it in an array, and then the second input places in the array. If we had a third input, you could place that one in the array, and so on. So that is how you do part 2.